Hello, today we're talking about lesson 3.2, estimating products. And we're on page 109 of your textbook. So let's go ahead and get started. And so our unlock the problem today is the Smith family opens the door of the refrigerator 32 times in one day. There are 31 days in May. About how many times is it opened in May? So underline any information we're going to need. Well, they opened the refrigerator 32 times in one day. There are 31 days in May. About how many times did it open in May? So we know that since it's 32 times in one day and there's 31 days in May, that we would be multiplying this problem because there's 31 times 32. And we're eventually in this chapter, we're going to get to a way of multiplying that. But for now, we're just going to estimate the product, and that's going to help us later in the chapter to see if our answers are reasonable. So one way we can estimate products is to use rounding and mental math. Okay, well, we know how to round numbers to the nearest tens, so that's not going to be a problem, right? So estimate 32 times 31, round each factor. So 32 would get rounded to 30. 31 would get rounded to 30. Well, now that's exactly what we just did yesterday. We can go use mental math and take the non-zeros, the basic math fact, 3 times 3. Well, that's 9. So 9. And then we notice there's a 0 in this 30, and there's a 0 in this 30. So my answer has to have the 2 zeros from the tens. So they opened the refrigerator door about 900 times during the month of May. Over here in the math talk, will the actual number of times the refrigerator is opened in a year be greater than or less than 900? Well, it's got to be greater than 900, right? That's just May, and they opened it 900 times. So clearly, it would be significantly more than 900. Number one, on average, a refrigerator door is opened 38 times each day. About how many fewer times in May is the Smith's family refrigerator door opened than the average refrigerator door? So on average, it's 38 days. So on average. So that means some are going to be less, some are going to be more. But on average, 38 times per day. About how many fewer times in May is the Smith's family refrigerator door opened? Well, we know the Smiths are about 900. Okay, about 900. So let's figure out what the typical or average number of times a refrigerator door is open. So 38, we know that's close to 40. We already said that 31 gets rounded down to 30. So now we would go 4 times 3. That's 12. That's the basic math fact, 4 times 3. There's a 0 in 40. There's a 0 in 30. So my answer is 1,200. All right, so the typical door is opened 1,200 times. The Smith's door was opened 900 times. So we need to subtract because it asks us how many fewer times. So we know that 0 take away 0 is 0. So we're going to do that for both the ones and the tens. I can't take 9 tens from 2 tens. So I'm going to regroup the 1,000 as 1,000. So now I have 1,200s, and 1,200s take away 9 is 300. So about 300 times fewer. All right, so let's go to page 110. Okay. And so all 24 light bulbs in the parks in the Park family's home are CFL light bulbs. Each CFL light bulb uses 28 watts to produce light. About how many watts will the light bulbs use when turned on all at the same time? Okay, so we know that they have 24 light bulbs. We know that each bulb uses 28 watts. How about, so that's a clue that I am estimating, when turned on all at the same time. So all 24 lights at the same time. And so another method we could use is a concept known as compatible numbers. You talked about this concept in third grade. And compatible numbers are numbers that are easy to compute mentally. I often like to think of compatible numbers as like multiples of 25 because it's really easy to multiply quarters. Okay. And so what they're saying is 24 times 28. 24 is very close to 25. So let's change the 28 to 30 and change the 24 to 25 because now we can think of the 24 as 25 times 3. 3/4 is 75, right? We don't really need to think about that. We know that there's 4 quarters in a dollar. So if you have 3, that's 75 cents. If you have 2, it's 50 cents, so on. So 25 times 3 is 75. And we have to add the 0 from the 30. So about 750 watts if they turned all 24 lights on at the same time. Now, it would be less. The actual answer would be less because we added one extra light bulb and we also rounded up the watts. So it's going to be lower than 750, but that's about what it would be. So now let's estimate these. 26 times 79. And our directions for this one is round to the nearest 10. So 26 round to the nearest 10. So they got the 2, because that's in the tens place. The 6 is 5 or greater. So we're going to round that up to 30. Great. Now 79. So again, we're going to round to the nearest 10. The 9 is greater than 10. So we're going to make that 80. Well, the basic math fact is 3 times 8. 8 sets of 3 or 3 sets of 8s. That's 24. 8, 16, 24. And then there's 2 zeros from the tens. So 26 times 79 is about 2,400. 2,400. Now they want you to use the same numbers, but use the strategy compatible numbers. Well, again, 26, that's real close to 25. And we're going to round the 79 up to 80. Okay, so this time we have 8 quarters, right? Well, 4 quarters is $1 or 100 pennies, right? So if we have 8, that's twice as much. So we're going to have 200. 8 times 25 is 200. And we have to add the 0 from the tens. So 26 times 79 using compatible numbers is about 2,000. So now it's number 2 says, explain why 2,400 and 2,000 are both reasonable estimates. Well, both of our estimated amounts use numbers close to the original numbers or to the original factors. Okay. And so basically, so estimates would be reasonable. So the estimates would be reasonable. Okay, for instance, What if instead of 26 times 79, instead of making that 30 times 80, what if I did, I don't know, 10 times 100? Well, now those numbers aren't really close to our original factors. This one's only 4 off. This is only 1 off. If I change that to 10 and that to 100, we're significantly off of our original factors. All right. In what situation might you choose to find an estimate rather than an exact answer? I don't know. I might estimate to find out if I have enough money to buy ten sets of beach chairs that cost $26 each. Something like that. So sometimes when we're in a store, we want to be able to quickly multiply in our head to see, oh yeah, I can't get that many, so I'll get this number of chairs. All right, number 1, page 110. So we're going to use our two methods, rounding and compatible numbers. Compatible numbers, I would use if the number is close to a 25. Okay, so just keep that in mind. If it's close to 25, let's use that. So to estimate the product of 62 and 28 by rounding, how would you round the factors? Okay, well, 62 would round to 60. And 28 would round to 30. So what would the estimated product be? So we're basically saying 60 times 30. The basic math fact is 6 times 3, which is 18. And then we put the 2 zeros from the 2 tens. So our estimated product would be 1,800. Simple enough. Okay, page 111. Number 2, estimate the product and choose a method. Okay, so we have 2 methods that we can use, rounding to the nearest tens or using compatible numbers. So this first one, let's round to the nearest tens. Okay. 96 would actually round up to 100. 34 would round down to 30. So we have 30 times 100. Well, our basic math fact is 3 times 10. 3 times 10 is 30. Put the 2 zeros, so our estimate's about 3,000. 47 times 39. Again, I'm going to use the rounding to 10 method. So 47 becomes 50. 39 becomes 40. 5 times 4, the basic math fact, is 20. And then I'm going to put the 2 zeros from both factors. So 2,000. 78 times 72. So 80 times 70. The basic math fact, 8 times 7. 8 times 7 is 56. If I didn't know that, I would probably start with 8 times 5, which is 40. Then add 8 more, which would be 48. And then I would add the 7th 8, which gets me to 56. So 56. But I'm not done because that was just the basic math fact. Both of my factors end in 0, so I'm going to put the same number of zeros in my answer, 5,600. Describe how you would know if an estimated product will be greater than or less than an exact answer. If both factors are less than the original, the product would be smaller. The actual product would be greater. If both estimated factors are less than the original, the product would be the estimated product would be less than the original. Okay, so it wants to know, how do you know if an estimated product will be greater than or less than the exact answer? So if we are estimating our factors and we're saying that we're going to round down on both of them, so we're actually making them smaller than the original factors. In that case, our estimated product will be less than the exact answer. And so the alternative would be, what if both factors were greater when we estimated? If both factors were greater, our estimated product would be greater than the original. Okay. So now let's continue with number 5. 41 and 78. Okay. These are still, I would still use the rounding method for this one. A basic math fact, 8 times 4 is the same as 8 times 2 doubled. 8 times 2 is 16. 16 and 16 is 32. And I'd put the 2 zeros from the 2 tens from both factors. Now 61, I'm going to use compatible numbers actually. It does look like we rounded the tens though, but technically these are quarters, right? So the basic math fact, 7 times 5, 35, and put 2 zeros, 3,500. 34 times 80. Okay, I don't need to do anything with the 80. Let's just leave it as 80. The basic math fact, 3 times 8 is 24. 2 zeros in total for the factors. So my product has 2 zeros, 2,400. Now 84 times 23. 23 is close to 25, right? I think I'm going to use compatible numbers on this one. Okay. So 8 quarters is 200. And we have 1 zero. So my estimate is 2,000 for number 8. Number 9, 27 is also close to 25. And so we're going to go 25 times 60. And this time, 6 quarters. How much is 6 quarters? 4 quarters is a dollar, right? Or 100 pennies. So if I give you 2 more, that would be 6 quarters. So 2 quarters is 50 cents plus the 4. So we'd have 150 pennies or $1.50. So 150. And then we have 1 zero in the number 60. So we're going to add that 0 to my product. So $1,500. 45 times 22. This one we're going to go, I think we should round to tens. 45 gets rounded up to 50 because the 5 is closer to 5 or more we round up. It's halfway in between. And 22, we'd round down to 20. The basic math fact is 5 times 2. 5 times 2 is 10. And I see that there are 2 zeros in in my factors, so I'm going to put 2 zeros in my product. Number 61. Estimate the product, choose a method. So this one, 61 times 30, I'm going to round down. Both of those numbers will get rounded down. 6 times 3 is 18, and there are 2 zeros in each of the factors, so 1,800. 52 will get rounded down to 50, and 68 gets rounded up to 70. 5 times 7 is 35. There's a 0 in 50, there's a 0 in 70, so my product has 2 zeros at the end. 26 times 24, that's close to 25, so I'm going to use compatible numbers. 44 times 40, 4 quarters is 100 pennies, and the 1 zero from the 40, we get 1,000. Okay. If you did 30 times 40, you would get 1,200. 57 times 69, that's 60 times 70. 6 times 7 as a basic math fact is 42. Each of the factors ends in a 0, so my product has 2 zeros. Right, number 15. So I'm going to round that up to 60. I'm going to round 39 to 40. The basic math fact is 6 times 4, which is the same as saying 6 times 2 doubled. So 6 times 2 is 12, double is 24. I have a 0 in 60, I have a 0 in 40, so my product will end in 2 zeros. 51 times 80, I'll round down to 50. 81 will get rounded down to 80. My basic math fact is 8 times 5. I know that to be 40. 50 ends in a 0. 80 ends in a 0. So my product is 4,000. 47 times 32. I'm going to round 47 to 50. And I'm going to round 32 down to 30. We have a basic math fact of 5 times 3, which is 15. And there are 2 total zeros in my factors. So my product will have 2 zeros. Number 18, I'd round 49 up to 50. I'd round 64 down to 60. My basic math fact, 5 times 6 or 6 times 5 is 30. And there are a total of 2 zeros in my factors. I should stress that when I say 2 zeros, they end in zeros. If the 0 was in the middle of a 3-digit number, that concept wouldn't matter. We're only counting tens. Okay, so we only count the zeros if they end in a multiple of 10. All right, find 2 possible factors for the estimated product. So we need to know 2 factors that if you multiplied them would be 28. Well, I know 1 and 28. I know 2 and 14 is 28. And I know 4 times 7 is 28. So I think I'm going to use that basic math fact. Now, they want to know 2 possible factors for the estimated products. So what they're saying is, when we multiply, we want to wind up with 40 and 70. So I could have 43, right? That would round down to 40. And I could have, 68. 68 would get rounded up to 70. Or I could have 73, something like that. Okay, so I just need both of these numbers to round to the correct value of the basic math fact. So 43 would become 40, 68 would become 70, 7 times 4, 28, and then the 2 zeros. 8100. Well, I know 81 is 9 times 9. 81 is 9 times 9. So I need two numbers that are going to round to 90. Well, let's take one to be 87. What would you round that to? That would be 90. And let's go one that's 93. That would round down to 90. So it would be 90 times 90. 90 times 90, 81. So let's do that. So you understand what I'm focusing on. Okay. Our factors have to be a two-digit number, but I'm just using a basic math fact to get started. 5,600. So I need to know two numbers that multiply to 56. And I know that there's more than one, but I'm going to use the basic math fact 7 times 8. So to round down or up to 70, it needs to be 65 or greater or less than 74. Okay, if I get 75, I round up to 80, which would work for the 8, right? Okay, so I'm going to use 66. 66 would get rounded to 70. So basically what we're looking at here, there's multiple possibilities. Okay, any number that would round to the factor we need. So 66, 67, 68, 69, 71, 72, 73, 74. Those would all be possibilities for 7. For 80, the largest number I can have is 84. The smallest number I can have is 75. So any of those numbers would work. And now finally 24. Well, I think I'm going to use 4 and 6. So it's actually 40 times 60, right? So I need, let's go 41 times 61. Both of those numbers would round down to 40 and 60. All right. So those are just one possibility for those answers. There's many possibilities. All right, number 23. On average, the refrigerator door is opened 38 times each day. Len has 2 refrigerators in his house. Based on this average, about how many times in a 3-week period are the refrigerator doors opened? Okay, so first off, it's not 38 times the days, because he has 2 refrigerators. Okay, so just keep that in mind. He has 2 refrigerators. So there are how many days in a 3-week period? 7 days per week. 7 times 3 is 21. Times 2. Why am I doing times 2? Because there's 2 refrigerators. All right, so let's round, because it does say about how many. So 38 is close to 40. 21 is close to 20. And then we're going to double that answer. Basic math fact of 4 times 2 is 8. There's a 0 in 40. There's a 0 in 20 at the end. So it's 800 times 2. 8 times 2 is 16. And there's 2 zeros in 800. So our product is 1,600. About 1,600 times. The cost to run a refrigerator is about $57 each year. About how much will it have cost to run by the time it's 15 years old? All right. So So I see a keyword there, about, so I don't need an exact answer. $57 each year for 15 years. Okay. So our basic math problem would be 57 times 15. Well, 57 is close to 60. And 15, I'm going to round up to 20. 6 times 2 is 12. And then we have the 2 zeros. So it costs about $1,200 over the life of the refrigerator, or over the 15 years. 25. If Mel opens his refrigerator door 36 times every day, about how many times will it be opened in April? Will the exact answer be more or less than the estimate? And explain. Okay, well, I know there's 30 days in April. So we're going to have a problem of 36 times 30. Okay, so I'm not going to do anything with the 30. I'm going to leave that alone. I'm going to round the 36 up to 40. So I'm increasing the estimated factor. So my exact answer would actually have to be smaller than my estimate. So 4 times 3 is 12. And there's 40 ends in a 0, 30 ends in a 0. So we're going to have 2 zeros in our product. So it's going to be about 1,200 times. Now that's part 1. Now it says, will the exact answer be more or less than the estimate? The exact answer will be less because we changed 36 to 40, which is an increase, which is bigger than the original. All right, 26. What question could you write for this answer? The estimated product of two numbers that are not multiples of 10 is 2,800. So this is like the problems we've been doing on 19 through 22, where we want the value when we round the numbers to be something like 70 times 40. Okay, so it's basically, what is the estimated product? What is the estimated product of 43 and 68? Okay, so 43 would get rounded to 40, 68 would get rounded to 70. All right, number 27. What is a reasonable estimate for the product? Write the estimate. An estimate may be used more than once. All right, 26 times 48. So we might use compatible numbers, which would be 25 times 50. Okay, so that one could go there. 21 times 22, I could round down to 20 times 20. Yeah, that's a possibility. 28 times 21, that could get rounded to 30 times 20. And 51 times 26, 51 gets rounded down to 50. And 26 could be 25. Okay, so we're going to say 25 times 50. Okay, and it could have been 50 times 30, but that's not one of my choices. So it had to be 25. So that's it for estimating products. Basically, we can use compatible numbers, like multiples of 25, or if the number is close to 25, use that. And then we also use the rounding and mental math for that. So that's it for lesson 3.2. So until our next lesson, where we talk about area models and partial products, may the numbers always be in your favor.